Hello. In this video, I'm going to go over solving an example problem of analyzing stress at a point. Okay, so here we have our example problem set up. We have our plane stress. In the x-axis, our normal stress is 12 ksi. In the y-axis, normal stress is -6 ksi, putting it in compression. And our shear stress is 10 ksi. What we want to do is find the stress on this inclined plane here, which makes a 60-degree angle from the horizontal. Now, the way to go about this is that you apply, as you can see on this figure, we apply an x1 and y1 axis onto it, where the x1 from x to x1 makes an angle theta. This is our transformation angle. You may also know x1 and y1 to be called as n and t. And that's because x1, also known as n, you put normal to this inclined surface. On this figure here, it's shown. So when you put x1 normal to this 60 degree, that makes it from x to x1 counterclockwise is 150 degrees. And of course, y1 has to be a further 90 degrees from that. It's a 90-degree angle from x1, which puts it tangent to that inclined plane. So once you have that, here are the main shear stress equations. You put in the plane stress, the original plane stress variables that we have, and then here we have the angle that we can change. It's 2 times theta. In this case, 2 times 150 degrees is 300 degrees. And here I have all the equations solved out, where sigma x1 comes out to -1.16 ksi. Sigma y1 comes out to 7.16 ksi. This isn't actually put on the figure because we're mainly worried about x1 and the shear stress. And tau x1 y1 equal to tau y1 x1 comes out to 12.79 ksi. And a thing to remember is that in our equations, here we have a check equation, where the original sigma x plus sigma y has to add up to the same amount as what the transformed sigma x1 and sigma y1 come out to. So here we have our check going on. It's 12 minus 6 and -1.16 plus 7.16. They both come out to 6 ksi. So we know that this is working out properly. Now what we can do is look into how to solve this from using our MechMat software. So let's bring up our stress transformation, and we can put in the problem information. So it's 12 ksi, -6 ksi, and 10. And remember, as long as you stay consistent with your units, it'll work out. We're putting in ksi, so the numbers it spits out are going to be ksi. Hit OK. Here's our plane stress, and it starts out with 0-degree transformation. So the output answers, as they should be, are the same as the input. And you can see if you drag the slider bar here, it automatically outputs these answers. It does these calculations for you. So it's pretty quick. Once you have your angle, you just throw it in, you have your answers instantly. However, you can see that it only goes up to a maximum value of 90 degrees, which won't work with our theta of 150 degrees. So how do we solve this? Well, to solve in MechMat, the theta has to be less than or equal to 90 degrees. So in order to change this so that our theta is less than 90 degrees, instead of putting x1 normal to the inclined surface, like this figure here. You know, it's a setup of how we just solved it earlier. What we can do is, instead of that, we can set x1 to be tangent to the inclined surface, which now makes y1 normal to the surface. Now, doing this, you will end up with the same answers. It's just the answers are going to be associated with different axes. They'll be labeled differently, and the sign may change. Otherwise, it is the same answer. So, by applying it like that, now theta is just at 60 degrees. So we can put in here 60 degrees, change it, boom, we have our answers. And you can see with the check, these answers, they still add up the same. The check is still working correctly. It's just that now the x1 and the y1 values are swapped, as they should be. One thing to note is that now the shear stress is negative. And that's because on this figure shown, x1, the positive direction, is moving upward, and as well as that would be the positive direction of the shear stress. But as seen here in the original setup, the positive of the y1 was down, and so was the shear stress down. And that just means that in this original problem, the shear stress came out to be positive with respect to that direction, that positive direction. So the shear stress is moving downward. And because this value comes out negative, that means it's negative with respect to this positive. So it's also going down because positive is now up. So it basically, it will work out. And once you get the hang of it, you can just make that change and get your answer instantly. It's just you have to keep track of now which the sign convention is and which answer is associated with which variable, because now they're different. But overall, it's pretty simple. And kind of the main thing that helps you with that is just keep a visual look on it. You know, once you can see visually what's happening, which the figure helps you with, then you can see what's happening fairly easily. But that's all there is to it.